Previously, we have considered the Baker-Campbell-Hausdorff formula. Baker-Campbell-Hausdorff. Which actually relates to operator product over exponential lambda a, b exponential minus lambda a, which is actually expressed by this formula lambda a b plus lambda square over 2 a b dot dot dot. So using this expression, that we also have a relationship that exponential a plus b is given by exponential a, exponential b, and exponential minus c a b. So if you apply this Baker-Campbell-Hausdorff formula to the Hamiltonian, then the infinitesimal component of the evolution operator epsilon h is given by exponential minus I over h epsilon p square over 2m plus 3 over x can be approximated by exponential minus 2m I e p square over h times exponential I v over x epsilon over h. Then we can calculate the probability amplitude of xb, tb, xa, ta, which is given by the following integral dxn xb exponential minus h I over h epsilon h xn exponential minus I over h epsilon h xn minus 1 and dot 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 x1 exponential minus I over h epsilon h xa. Then using the approximated expression of a Baker-Campbell-Hausdorff formula dx1 dxn and dp0 dpn and xp exponential minus I over h bar 2m epsilon p square pn minus I over h 3 x epsilon x n minus 1 and it continued to be x1 exponential minus I over h epsilon p square over 2m p dot p0 exponential minus I vx over h epsilon xa. So this integral can be written as a product form I equal to 1 to n txi j equal to 0 to n tpj, and xb exponential minus I epsilon over h p square over 2m pn exponential minus I vx over h epsilon xn x1 exponential minus h a p square over 2m p0 exponential minus I vx over h xa. Then it can be written as a further simplified form exponential minus I pn square 2mh epsilon I vx over a xp pn xn exponential minus ip not 0 2mh epsilon exponential minus h I vx epsilon x1 p dot xa. So by the way, we have this formula xb pn xn is 1 over 2 pi h exponential hi xb minus xn pn. So if you use this relationship, then this integral becomes 1 over 2 pi h n plus 1 dxi dpj exponential minus 2mh ipn square epsilon plus h bar I xb minus xn pn minus h bar I vx epsilon dot exponential minus ip square over 2mh epsilon plus h bar over I x1 minus xa p0 minus h bar I vx xa epsilon. And before we proceed, we can utilize this Gaussian integral. Minus infinity to infinity exponential minus ax squared dx is square root of pi over a. Then what would be the value of this y squared dy? So we can start with exponential minus infinity exponential minus I a y squared and I pi over 4 dy. So Let's substitute I pi over 4y as y prime. That means y is exponential minus I pi over 4 y prime. Y square is exponential minus I pi over 2 y prime square is minus I y square, prime square. So from minus infinity to infinity, exponential minus I a y square exponential I pi over 4 dy is same as a y prime square dy prime is pi over 4. So as a result, exponential minus infinity to infinite, exponential minus I a y square dy is pi over a divided by exponential I pi over 4, the same as I a over pi. So using this, we have the following formula. We can transform this integral pn square epsilon plus h bar of I pn xb minus xn tpn. We can factor this into 2m over h, i.e. pn square minus epsilon over 2m xb minus xn pn tpn. So we can written down as minus infinity to infinity exponential minus 2mh I epsilon pn minus epsilon over m xb minus xn square minus epsilon square m square xb minus xn square tpn. So this integral becomes exponential minus 2mh I epsilon pn minus epsilon over m xb minus xn square tpn times 2 epsilon h I m xb minus xn square is I epsilon 2mh pi exponential 2 epsilon h I m xb minus xn square. Wow. So as a result, this probability amplitude xbtb over xata becomes 1 over 2 pi h n plus 1 times I epsilon 2 mh pi n plus 1 times, now we have only the x integral dxi exponential 2 epsilon h I m xb minus xn square x1 minus xa square times exponential minus h I over h epsilon Vxn Vxa by the way, exponential I epsilon over h 2 e square m xb minus xn square 2 epsilon square m x1 minus xy square minus 3xn minus 3xa. It can be written as exponential I epsilon over h m xb minus xn square minus 3xn plus 2 epsilon square m x1 minus xa square minus 3xa. This can be written as exponential I over h over the summation becomes integral ta to tb m over 2 tt dx square minus 3x tt. Here we have used the fact that tt dx is epsilon over x I minus xi minus 1. And this is a name, special name called Lagrangian. Then this probability amplitude can be written as the following formula. M over 2 pi I epsilon h n plus 1 exponential I over h ta tb Lagrangian t tt. And we call this part as a path integral, integrating over all paths. So this way, x over t, and then means integrating over all paths. So we will stop here today, and next time we will consider the special cases.